Consider the motion of a body in a vertical circle. Let this be the body of mass m, rotating in a vertical circle. The different forces acting on the body are: one is the weight acting vertically downward, like this, mg, and if you consider this angle as theta, that is, if you extend this straight line and if you mark theta as this, then this will be mg cos theta. This will be mg sin theta. Clear? Now, suppose this be the, see, this one is the radius of the circle. Also, this length will be the radius of the circle. Suppose this mass is at a height h from the bottom of the circle. That is, let's call this point A. Suppose this mass is at a height h. Then this length is equal to r minus h. Since the total length OA is the radius of the circle. Clear? Also, this angle will be theta. This angle, these OA and this MG are parallel lines, so both these angles are equal. Clear? Now, how will you find the velocity at the point? Let's call this point P. How will you find the velocity at the point P? For that, we are just considering the conservation of energy, which means the total energy at the point A, is equal to total energy at the point B, not B, P. And you know, total energy at the point A will be sum of the kinetic energies and potential energies at A. That is, kinetic energy at A plus potential energy at A. Similarly, total energy at P will be kinetic energy at P plus potential energy at P. Now you know, this velocity will always be tangent to the circle, which means at the point A, the velocity will be like this. Let's call that velocity as u. Similarly, at the point P, since it is tangent, the velocity will be like this, v. Now you know, the kinetic energy at the point A will be half m u square plus, since there is no height at the point A, potential energy at A is 0. Similarly, the kinetic energy at the point P is equal to half m v square plus, since there is a height of h when the mass is at here at the point P, we have potential energy is equal to mgh. So you can take this m outside, so half mu square, or just write like this, half mv square plus mgh. Now you can cancel every mass m. Also multiply the whole equation with the 2. So this will be u square equal to, call this as equation number 1. What I am doing is multiplying this equation number with the 2. So 2 into 1 by 2 will get cancelled, so you will get u square plus v square plus there is a 2gh. Implies, if you take this 2gh to the left, then you get v square is equal to u square minus 2gh, or v is equal to root of u square minus 2gh. So this is the expression for velocity at any height h in a body in vertical motion. Now let's find the velocities at different points A. Let's call this point, call this point B. Let's call the highest point C. Now let's find the velocity at A, B and C using this equation. velocity at A will be, we have the equation u square minus 2gh height at A. Since there is no height at A, this term will be 0. So VA is equal to root of u square. That we know, we already do u. No need to find that. It's already u. Velocity at A is u. What about the velocity at B? We have velocity at B is equal to, if you substitute this in the equation, u square minus 2g, since the height is OA. Height at the point B is equal to OA, which is equal to the radius R. So u square minus 2gr. So that's the velocity at B. What about the velocity at C? Again, you substitute that in the equation. In the equation we wrote in the box. So this is equal to u square minus 2g. This time height is, since this is the height will be, there is an extra r plus r, though, so the height will be 2r. Clear? So this is equal to 2r, which means velocity at the maximum height will be u square minus 4gr. Clear? These are the different velocities at the point for a body in vertical motion. Now, how will you find the tension in the string at any point during the vertical motion of a body? Let's consider the same circle with center O. This is the rope and this is the mass M tied at one of its ends. Now the forces acting, let this be the vertical and let this angle be theta. The different forces acting on the body, on the mass M are, first one is mg, that is acting downward. If this angle is theta, this also will be theta, and this length will be mg cos theta, and the perpendicular component will be mg sin theta. Clear? The tension will always be in a direction from, let's call this point P, from P to O. So this is the direction of tension. Clear? So the net force acting along the line OPR, since tension is in the inward direction and mg cos theta in the radially outward direction, the net force, or since the force acting towards the center is centripetal force, then you call the net centripetal force is equal to the difference of these two forces, which means T minus mg cos theta. That is T minus mg cos theta. You know the equation of centripetal force is mv square by r. mv square by r. Therefore, T minus mg cos theta is equal to m by r. You know the equation v square is equal to u square minus 2gh. That we already derived earlier, since this is the height. This expression we already have derived in the last session. So you have to substitute u square minus 2gh for v square in here. So this is equal to u square minus 2gh. Again, this is cos theta, this is theta, this length is r minus h, since the total length is r, and also the length OP is equal to r, radius of the circle. Let's call this point PQ and let's call this point A. If you consider the triangle OQP, let's consider this triangle OQP, you have cos theta is equal to adjacent side, that is OQ, divided by the hypotenuse OP. That is cos theta is equal to OQ is equal to r minus h divided by OP is equal to r. Instead of cos theta, let's substitute this value. So this will be T minus mg into r minus h by r is equal to m by r u square minus 2gh. Now let's simplify this expression. If you take, let's simplify this expression. It is T minus m by r. If you take this m by r is taken outside, if you take this g to inside, this will be gr minus gh equal to m by r into u square minus 2gh. If you take this mgr to the right, you get t is equal to m by r gr minus gh plus m by r u square minus 2gh. And again from these two terms you can take m by r outside. So this will be m by r into gr minus gh plus u square minus 2gh. So this will be T is equal to m by r minus gh minus 2gh will be minus 3gh. That is, if you take the u square first as the first term, then it will be u square plus gr minus a3gh. So this is the expression for tension at any point during the motion of a body in vertical circle. Now let's find out the tension at different points. First we are going to find the tension at the lowest point A, then the tension at the highest point C. For that, let's take the value of h in these two different positions. So you have the final expression T is equal to m by r u square plus gr minus 3gh. Now you have to find tension at the point A. Let's call that as TA. Now the variable of height the height at the point A is 0. So tension at A is equal to m by r times u square plus gr minus 3gh. This term will be 0. Clear? Since there is no height. 0. So tension at A is equal to m by r times u square plus gr. Let's call that as equation number 2. Now what about the tension at the highest point? Tension at A. Tension at the highest point C. We have Tc is equal to m by r into u square. We have the equation. Let's write that equation again, the final expression, because I just erased that equation. It will be useful if you look at that equation. This is equal to m by r times u square plus gr minus 3gh. This is the expression for tension at any point. Now we are considering the tension at the highest point C. Since at the highest point, you know h is equal to 2r. You have u square plus gr minus 3g into 2r. So this will be Tc equal m by r u square plus gr minus 6gr. So this will be This will be tension at C, Tc is equal to m by r u square. Gr minus 6gr is minus 5gr. Clear? Let's call that as equation number 3. So tension at the highest point Tc is equal to m by r u square minus 5gr. Now, what is the difference in the tensions at these two extreme points? That which means the difference of tension at the lowest and highest point. Let's call that as difference in tension delta T. We have TA minus Tc. So what you get if you do this? This will be m by r. TA will be u square plus gr minus m by r u square minus 5gr. See, so if you simplify this, you will get delta T, difference in tensions at the extreme points, m by r into u square plus gr minus u square plus 5gr. Clear? This u square and this u square you can cancel. M by r into gr plus 5gr is equal to 6gr. Cancel this r and r. This will be 6 times mg, or 6 times the weight of the body. Weight of the body. Clear? Now let's find out what is the minimum velocity of projection at the lowest point for looping. We have tension T at any point is equal to m by r times u square plus gr minus 3gh. This is the expression for tension at any point of motion of a body in vertical circle. Now at the highest point C, tension at C will be m by r times u square plus gr minus, at the highest point you have h is equal to 2r. No doubt. This height is 2r. 2 times the radius of the circle. So this will be 3g times 2r. So tension at the maximum height will be m by r u square minus okay, plus g. There is g plus gr minus 6gr, so minus 5gr. Clear? See, 3 times 2 is 6. So gr minus 6gr is equal to minus 5gr. So this is the tension at the highest point. Let's call that as equation number 1. So in order to complete the circle or looping, which means since the body has to continue the circular path, the tension at the height C must be greater than 0. If it is less than 0, the body will come back or it will slack. That's the condition. So at the highest point, the tension can't be 0, or at least it must be greater than 0. So which means the condition for looping will be the tension at the highest point must be greater than or equal to 0. That is, Tc must be greater than or equal to 0. If it is greater than 0, then it is fine. At least it should be equal to 0. So substituting, you get m by r times u square minus 5gr must be greater than or equal to 0. Mass can't be 0, radius can't be 0. So this term u square minus 5gr can be greater than or equal to 0, or u square greater than or equal to 5gr. That means u, taking the square to the right side, it will become root. So u greater than or equal to root of 5gr. So root of 5gr. So this is the minimum velocity at which the body must be projected from the point A so that it will continue looping. So there arises a question, what is the velocity at the point C? For that, you can substitute, you can take the equation number 1 we first derived, that is the expression for velocity at any point. And we have velocity at any point v is equal to root of u square minus 2gh. Clear? U square minus 2gh. Now, we know the velocity of projection is root of 5gr. So, root of 5gr whole square minus 2g into, at the maximum height c, the height is 2r. So, this will be root of 5gr minus 4gr. This is equal to root of gr. So, the velocity at the maximum height will be c. Clear?